Okay, so now in chapter 4 we were looking at discrete probability distributions. And looked at two particular examples, the binomial probability distribution and the Poisson probability distribution. Now in chapter 5 we'll be looking at continuous probability distributions and looking at two examples, the normal probability distribution and the uniform probability distribution. Now the normal probability distribution is probably the most important probability distribution in statistics. So let's look at some conditions of the normal probability distribution. First, it's symmetric. That means it's symmetric about the mean. It's bell-shaped. And it's described by this formula here, which is very messy, but if you notice in this formula we have a mean and a standard deviation. So every normal probability distribution is defined by its mean and its standard deviation. Now, if you think about it, height is normally distributed, but the average, the mean height of a woman is going to be different than the mean height of a man, which is going to be different than the mean height of a 4-year-old, and all of them have different values for variability or different standard deviations. So this formula, if we wanted to do all those different possible normal probability distributions, we'd have to use this formula. So let's figure out another way to do this problem without that really messy formula. Before we move on to and look at the normal distribution, let's look at the other example we're looking at, which is the uniform probability distribution. The uniform probability distribution is a distribution such that all the values are spread out evenly over the range of possibilities. In other words, it's going to make a rectangle that where on the top is pretty much almost flat. So if we were going to do an example of a uniform probability distribution, let's look at problem in chapter 5, section 2, number 5 in the problem set. That problem asks us to find the probability that x is less than 10 for a uniform distribution. Whereas in Minitab, we're going to go to Calc, then probability distributions, and then you're going to see in the next menu drop down, and one of the choices is going to be uniform. And then a box is going to come up and it's going to ask you to input a lower limit and an upper limit. For this particular problem, it's given that the lower limit is 6 and the upper limit is 12. Our input constant is always this number right here. So under input constant, remember not input column, but input constant, enter in 10. And our answer then is going to be 1 minus the Minitab answer, because if you remember from what we looked at when we're doing the discrete probability distributions, if I'm looking for a greater than probability, the answer is always 1 minus the Minitab answer. Why don't you pause this PowerPoint for just a minute, go on Minitab and see if you can get the same answer. The density curve is the graph of a continuous probability distribution, and it must satisfy the following. The total area under the curve is equal to 1. Every point on the curve must be greater than or equal to 0, because remember, area and probability are equivalent. So, and all probabilities must be greater than or equal to 0. And the area under the density curve does correspond to the same probability. So now we're going to look at how we get around having to use that very messy formula that we saw. And besides, we would have to be able to integrate that. So since Calculus 2 is not a prereq for this class, we're going to have to figure out another way to do it. But what we do is we go to the standard normal distribution, which means it's a very special normal distribution with the following properties. The mean will always be 0. The standard deviation is always 1. Now to find area for probabilities for normal distributions, we can use the table, and then we have to standardize all of our values ourselves. We learned how to standardize a value in chapter 2. Remember, z is equal to value minus mean divided by standard deviation. We saw that in chapter 2. Or an even easier way, and the way I prefer you to do it in this class, is using Minitab, and Minitab will standardize all our values for us. We're going to see an example of that in this lecture. But I do want you to be aware of how the tables work. So the table, first thing you need to do is convert to the standard normal. And you do so by using the z-score. Remember, z is equal to value minus mean, and that quantity is then divided by standard deviation. Then we go to table A2 in the back of your book, and the table always gives the area to the left. This is known as cumulative area, and it's also equivalent to the probability that z is less than or equal to the value you're looking at. With Minitab, there's one of the buttons at the top says Calc. When you click Calc, a menu drops down. Choose probability distributions, and then another menu drops down, and you're going to see the word normal. I believe it's second from the top. And click normal. And you're going to select cumulative probability if you're trying to find the probability that x is less than or equal to, or less than, in continuous distributions, less than, equal to, and less than or the exact same answer, some value x, or probability that x is greater than or equal to x. Remember, when we're doing this one, it's still cumulative, but then we have to do 1 minus our answer. If we're trying to find a particular value, for instance, the value that cuts off the top 10% from the lower 90%, or the percentile 20, which percentiles are values. Then we select inverse cumulative. We're going to see examples of using both of those in this lecture. Now, when we're looking at cumulative probabilities, there are 3 types of problems. The first one is a less than problem. So we're going to be looking for the probability that z is less than some number a. And this denotes the probability that the z-score is less than a, which is equivalent to the area under the density curve to the left of a. Then the answer that you get, either from the table or from Minitab, is the answer directly from the table or from Minitab. So let's look at an example. Now these examples come from the problem set at the end of chapter 5, section 2. This is number 9, and it says, find the probability that z is less than negative 0.25. So we go to Calc, probability distributions, normal. Since we're looking for a probability, we select cumulative probability. Now make sure the default setting is the mean being 0 and the standard deviation being 1. But make sure that the mean is set to 0 and the standard deviation is set to 1. Then enter under input constant, not input column, but input constant. Enter negative 0.25. Hit OK. And Minitab tells you the probability that z is less than negative 0.25 is 0.4013. Or this is equivalent to about a little over 40% of the density curve is to the left of negative 0.25. The second type of problem is a greater than problem. Here we're looking for the probability that z is greater than some value a. Remember, with greater than problems, we learned this in chapter 4, the answer is 1 minus the answer from either the table or from Minitab. Both of them give us what's known as cumulative area that is less than or area to the left of the value. So now we're looking for area to the right of A. So let's look at an example. Now we're looking at number 13 in the problem set, which says find the probability that z is greater than 2.44. Then we go to Calc, probability distributions, normal. Select cumulative probability. Make sure your mean is 0, your standard deviation is 1, your input constant is, oh, I'm very sorry, I entered in 2.33, so up here, let's enter in 2.33. And then 1 minus 0.99, the Minitab tells you 0.9901. But remember, since it's a greater than problem, it's 1 minus 0.9901, which is 0.0091. The next type of problem is between two values. So we're looking at probability that z is between a and b. In this case, you have to do the problem twice. First, you find the answer for b, then you find the answer for a, and you subtract them. So let's look at an example of that. This is number 17 in your problem set. We're trying to find the probability that z is between negative 2 and negative 1. We go to the same place, select cumulative probability, make sure the mean is 0 and the standard deviation is 1. I always enter in the larger value first, negative 1.00 under input constant. Then Minitab tells me the probability that z is less than negative 1.00 is 0.1587. Then I go back and do all this again. Calc, probability distributions, normal. Go through all the steps again, but this time I'm going to enter in negative 2.00. Minitab tells me that answer is 0.0227. Then the answer that z is between negative 2 and negative 1 is the larger value minus the smaller value, which is 0.1360. Now, if you mix this up and you subtracted this one from this one, you're going to get a negative number. And remember, probabilities can never be negative. They must always be between 0 and 1. So if you get a negative number here, you probably have just switched these two. Now, why don't you pause the PowerPoint for just a minute and go to Minitab and try these 3 problems on your own to see if you can do them. Now, remember, in real life, normal distributions all have their own individual means and their individual standard deviations. So there are 2 possible methods using Minitab, which is the one I prefer you doing, but I do want to show you, if you wanted to do it with the table, you're going to have to use this formula, value minus mean divided by standard deviation, and because the table is only the standard normal table. So let's look at example 5 in chapter 5, section 3, number 1. It says find the probability that x is less than 115. We go to calc, probability distributions, normal. But this time, we need to change the mean and the standard deviation. In this problem, we are told that the mean IQ is 100 and the standard deviation for IQs is 15. So we change these numbers and we put our input constant into 115. Now notice, Minitab now has value, mean, and standard deviation. So it can do that standardization formula for us, which it does behind the scenes. Don't even have to do it yourself. And it tells you the answer is 0.8413. So the probability that a randomly selected person has an IQ less than 115 is about 84%. Now, we haven't yet looked at an example where we use inverse cumulative probability, when we're given the area or the probability and we're trying to find the value. So here we're trying to find the IQ score that separates the top 15% from the bottom. What it's going to be, if 15% is in the top, then what's left in the bottom or to the left of this value, this IQ score, would be 85%. We go to the same place, calc, probability distributions, normal. But this time we select inverse cumulative probability. We do this when they give us the area shaded and they're asking us to find some kind of value. We're going to see later on a term called the critical value. That's a value. Percentiles are values. Quartiles are values. And an IQ score is a value. But remember, Minitab always uses cumulative area. That's area shaded to the left. So if we draw our bell curve, and if 15% is in the right tail, then 85% is to the left of that value. And Minitab wants us to enter in the cumulative area. So we enter in 0.85. And Minitab tells us that value is 115.55. So the IQ score that separates the top 15%, which is the same thing as percentile 85, is 115.55. All right, so that's the first part of the lecture for chapter 5. That's the end of this lecture. Now, go try some problems with Minitab if you like, and then come back, and we will be doing the second part of the lecture. We're doing sections 5.4 and 5.7. We'll be skipping 5.6.